Hello everyone, I'm François from Shakmat. In this video, we will have a look at the Battering Ram, which is a kick drum synthesizer we did in collaboration with a friend from Brussels, Marc Nostromo. The Battering Ram offers control upon 5 different parameters: pitch, click, depth, decay, and drive. The module can be triggered by hand thanks to the trigger button, which also shows the amplitude envelope, and it has, of course, a trigger input. Let's send a sequence in this input. Let's now have a look at the different parameters, and let's start with the pitch. So basically the pitch is the bass frequency root note of the kick drum. By default, the pitch potentiometer has a range of 2 octaves, but as we will see later in this video, we can swap it to a range of 5 octaves. It is possible to lock the pitch control thanks to the lock button, which prevents to accidentally detune the kick drum. Actually, the pitch potentiometer now acts as an octave switch, and as the range is 2 octaves, you can just go from 1 octave up or 1 octave down. Note that once you unlock the potentiometer, you need to pass by the previous value in order to have the potentiometer have an effect again on the pitch control. Let's now have a look to the click potentiometer. The click acts on the amount of a very snappy envelope applied to the pitch. Let's now have a look to the depth parameter. The depth parameter sets the amount of a pitch envelope. As you can hear, more depth brings us in a more 9/9 territory. Of course, you really need to check this video on a proper sound system or with headphones. Your laptop speakers won't render the sub-bass this module can produce. Let's now have a look to the force control of this module, which is the decay. Of course, this parameter acts on the decays of the kick drum. When setting this potentiometer fully clockwise, you can go to very long kicks, which is pretty handy to create long 808 subby bass drums. Let's now switch to the last control, which is the drive. You have two types of drive, the green one and the red one, which are switchable thanks to the drive button. First, the green type, which is a kind of one-stage wave folder, which adds subtly few harmonics and compression. Let's try different settings. Let's now switch to the red type, which is a more harsher clipping distortion. It reminds me a bit the kind of kick you have in gabber or hardcore music. As you can hear, by mangling those 5 parameters, you can create a very large panel of kick drum sounds. It is possible to set the level/amplitude of the kick drum produced by the Battering Ram. Let's first send the trigger pattern into the trigger in. To set the level, just hold the level button and turn the drive potentiometer. While holding the level, the 3 green LEDs shows the set level. When you don't edit the level, the 3 green LEDs simply show the amplitude of the kick drum. Once you release the level button, you will need to turn the drive potentiometer past its previous position to reactivate it. The drive button is blinking until the drive potentiometer passed this previous position. So let's redo the whole operation, set the level this way, and catch up the previous drive position with the potentiometer. Let's now have a look to the velocity input. This input is a unipolar CV input which accepts 0 to 5 volts. This input allows to control the level of the kick drum. Again, when no cable is inserted into the velocity input, pressing level and turning the drive knob acts on the level of the kick drum, but when you insert cable into the velocity input, this manipulation controls the velocity range. Right now the mod Medusa is modulating the velocity. By pressing level and turning the drive knob, we now can set the minimum level of the velocity, meaning at which level the kick drum will play when a 0 volt is received into the velocity input. While editing the velocity range, the green LEDs show the range of level, and when the level button is released, as you can see, the green LEDs will show the level of the played kick drum. Let's now check the envelope output, which provides the amplitude envelope of the kick drum. This output is pretty useful for a lot of different applications, like self-patching, or also when using the inverted version of the envelope to create ducking effects. Let's start a trigger sequence. This sequence is triggering the Battering Ram, and we have this small patch in parallel, which is a Banshee reach in noise mode and is sent into a Santos gate. Channel 2 of the Santos gate will act as a VCA. Let's open manually the VCA to hear the source. And let's now send the envelope output of the Battering Ram to control the VCA of the source gate. As you can hear, the noise envelope is following the amplitude envelope of the kick drum. It is possible to invert this envelope by pressing the invert button on the battering ram. This is pretty handy to simulate decay compression. By default, the envelope output provides a 0 to 8 volt envelope, but it is possible in the advanced option menu to change this range to 5 volt and also to have an inverted envelope with a negative polarity. Like any percussion module, the battering ram reacts to triggers. So each time the rising edge of a trigger is received into the trigger input, the module will create a kick drum sound. Trigger length won't have any influence on this sound. However, the battering ram has a gate mode, which adds a hold stage to the kick envelopes, and this hold stage will be as long as the gate received into the trigger input. So let's change a bit the patch and let's send the trigger sequence into the triple steeple. So the triple steeple has a lot of internal normalizations, and we can have the second channel releasing a gate long as the decay of the first channel. So acting on the first channel decay will act on the gate length. Let's activate the gate. So again, there are internal normalizations in the triple steeple. In this case, the release state of the first channel is controlling the second channel gate length. Thanks to this feature and the fact the module accepts volt octave control of the pitch, it is possible to turn the battering ram into a bassline / more conventional synthesizer. Now we will have a look to the HPF function of the battering ram. So this function activates a low-cut filter. It's a 30 Hz 3-poles low-cut filter. This filter will remove the infrasub frequencies, which can occupy a substantial portion of the signal's headroom. So those frequencies cannot be heard, cannot be reproduced by any sound system, but still will take quite a lot of headroom in your music. The Store and Recall button allows to take a snapshot of all the settings of your battering ram and then recall them on the fly. Let's do a quick demonstration of how it can be useful. Let's send this very original trigger pattern into the battering ram. Let's say you like those settings. In order to store all those settings, just press and hold the Store and Recall button for 2 seconds. Let's do some variation and a break by changing the different parameters of the battering ram. And when you want to go back to the store settings, just press briefly on the Store and Recall button. Note the Store and Recall button is now on because the potentiometers does not correspond to the stored values. Each time a potentiometer will pass by its stored value, the Store and Recall button will blink, and when all the settings will be recalled, the Store and Recall button will turn off. Let's now talk about the select bus. Actually, the Battering Ram has a non-volatile memory of 16 presets, which can only be accessed thanks to the Select Bus protocol. We will use an Harlequin's context, which can act as a Select Bus transmitter, sending store and recall messages to the Battering Ram. Now the Select Bus reception must be activated on the Battering Ram. Okay, we will now create a first preset. We do like this preset, so we will store it on the scene number 1 of the Harlequin's context. Let's now do a second preset. Let's store it on scene number 2. We can now recall the first preset and the second preset. Let's do a third preset for the scene number 3. This will be our fourth preset. So, as you can hear, we can recall the 4 presets. Okay, let's change this trigger pattern. Let's now sequence the Harlequin's context. Let's reduce the sequence to 4 scenes. And here we go. The Battering Ram has an advanced parameter settings, which allows to customize the module the way you want. To enter the advanced parameter menu, press and hold the lock and invert buttons for 5 seconds. In this menu, the green LEDs are doing a kind of bouncing ball animation, as the store and recall button is now blinking. In this menu, the lock button will change the range of the pitch potentiometer. When it's off, you have a range of 2 octaves as described before. When it's on, is 5 octaves, which is pretty handy to create tom and bass lines with a wider octave range. Now the gate button. This button will enable or disable the reception of Select Bus messages. When the button is on, the module will accept the Select Bus messages, and when it's off, it will ignore them. Next advanced parameter is the HPF button, which will act on the range of the envelope output. When the button is off, the range is of 0 to 5 volt, and when the button is on, the range is from 0 to 8 volt. Last but not least, the invert button allows to change the polarity of the inverted envelope. When the button is off, the polarity will be positive. So in this case, as the HPF button is on, we have a range of 8 volts. So inverted envelope will go from 8 volt to 0 volts. And now if we activate the invert function in this menu, the inverted envelope will go from 0 to minus 8 volts. Same principle applies when the range of the envelope is 0,5 volts. Thanks a lot for watching, and see you very soon.